This video is made for section 12.3. From the example in 12.2, we have four, this has to be erased, we have four airlines that have different ratings, okay? And we tested whether or we need to test whether population means are equal or not. So the null is they're equal. The alternative is the means are not all equal. From section 2, following the same thing we did in the last video, we do the ANOVA single factor. You probably see some range here that I did before, but we need to change it to this. It labels on first row alpha 0.05. This is the one that is advised to use for the exercise, and then the output range I'm going to select to start in that cell. I get my results, and from a p-value less than 0.05, I conclude that not all population means are equal. We reject the null hypothesis. You can also look at the critical value, which is less than the the F statistic is larger than the critical value, so therefore we reject the null hypothesis. Now in section 12.3, it says, okay, but which pairs or which airlines or which pair of airlines are the ones that are different or equal? Well, you can do what is called the confidence interval approach, which is the one in 12.3, and use the confidence interval of the population mean differences is equal to the sample differences, the sample mean differences, plus minus the corresponding t-value with alpha over 2 in the upper tail, times the square root of MSC times the ratio of 1 over the size of the sample 1 plus 1 over the sample size 2, which follows pretty much the formula that we used in the previous chapter. The confidence interval of mu equals x bar plus minus t times s over the square root of n. Remember, this will be x bar, sample mean, and then plus minus, this will be a margin of error. This is called the standard error, which is the standard deviation of the sample means. And similarly here we have the t, and this will be the standard deviation of the differences in the means. And we can use the same data that we have here. We have the averages here, and we have the MSCs right here. That's MSE in the formula. So let's look at let's do the case of Northern NWTA. Difference sample means. Let me increase this. Oops. This would be DA19 minus DA20. Well, I started with the parentheses, I didn't need it. And that would be the first part of the formula. The t-value is equal to what? Well, if we look at our table, 0.05 two-tailed test, this is a copy of the t-distribution, and 18 degrees of freedom, what we use, 2.101. Why do we use 18 degrees of freedom? 18 degrees of freedom is this, the degrees of freedom for the MSC, okay? And remember, the MSC is, in this case, degrees of freedom is n minus k, a total of 22 minus 4 airlines, and that'll be 18. And we need the the MSC. Let me just put directly times 1 over n1 plus 1 over n2. So this would be equal to 3302. This is the MSC right here. times 1 over the sample size is 4 here for northern, plus 1 over 5. Okay, and we can get the square root of that. Or standard error. And it's just simply the equal square root of B36. You can do all this in any way you want. The main thing is to obtain the results. And I think we will pretty much have everything. So we can have now an upper limit for our confidence level, and the upper limit will be equal to the difference, which is 905. Let me just type the numbers, plus the t-value 2.101, and this times the square root 3.85, well, 85.5, and that'll be the upper limit. And the lower limit, it'll be, let me just copy this, and it'll be just subtracting that. So the lower limit will be 0.95, the upper limit 17.15. If 0 is not in the confidence interval, then the two means are different. The farther away these two values are from 0, the more significantly different the two means are. Okay, so 0, since 0 is not within this range, then we conclude that these two means are significantly different. And we can try two other means, for example, Pocono and Branson. So the difference here is between Pocono and Branson, the average, the difference in the means will be 72. Well, let me just put the cell D21, that's Pocono, minus D22. Okay, are they significantly different? We are trying to investigate. Then the t-value here is the same. That doesn't change, using the same significance level and the same degrees of freedom. Now the MSE times, now we need to have the MSE times 3302 times 1 over the Pocono sample size, which is 7, plus 1 over the Branson is 6. Oh, I forgot the asterisk for times. All right, so that is the MSE times that, and the square root of that is the standard deviation. The 36, and the upper limit, you can just copy well, actually I copied values. This is 386 in this case, plus 2.101, that's fine, times the 3, in this case 196 or 197 to round it. So in this case the upper limit is 1058. If you copy this here and subtract, the lower limit is minus 286. If you notice, between these two numbers we find 0, so therefore the two averages are equal. Conclusion. they're not exactly equal, but they are not significantly different, in other words. So if you do that, if you do the same approach for every pair, then you get a confidence interval. And if 0 is in the interval, they are not significantly different. And if 0 is not in the confidence interval, they are significantly different. And how significantly different are they? Well, the farther away they are from 0, the difference, then, or the confidence interval, the farther away from 0, the more significantly different the two means will be. So that is the method shown in section 3.